Hi guys, if you're new here, welcome to Aisha.Academy. If you've watched my videos before, you know how we do. But this is paper 3 of the AQA GCSE November 2018 higher series. So I've already got paper 1 and paper 2 on the channel already. So this is the last one. So let's get right into it. Okay, so question 1 says the shape is translated by the vector 0, 4, and in which direction will the shape move? So we know in terms of vectors, the first number is your x, and this other number is your y. So that means that in this case, the x hasn't changed, but the y has been translated by 4. So if I quickly sketch a rough graph so you understand where I'm visualizing this. So let's say if you just, I don't know, you have a box. So if it's being translated 4, let's say that top bit of the box was 2, then that means the whole shape has moved up. So if it's moved up by 4, that would now become 6. So the shape would be moved up. So if it's a positive y value in your vector, it moves up. If it was a negative y value, it would move down. If it was positive x, it would move across right. If it was negative x, it would move left. So on to question 2. It says, what is 1.75 kilometers as a fraction of 700 meters? Well, if we convert 1.75 kilometers into meters, so to go from kilometers to meters, you times by 1,000. So 1.75 times by 1,000, that will leave you with 1,750 meters. And then because it's that as a fraction over 700, and we know this paper is a calculator paper, so you could actually just put this into your calculator. So if you put 1,750 divided by 700 into your calculator, that should give you maybe either just the answer straight as a fraction of 5 over 2, or it might give you 2.5, which as a fraction is 5 over 2. Okay, so moving on to question 3, it says the first 4 terms of a linear sequence are 3, 11, 19, and 27, and it wants us to express the nth term. So the first thing when it comes to linear sequences, you want to work out the difference between the numbers. So they've been added a, and plus a each time, which means the first part is going to be 8n. Then if I work out the first 3 terms of 8n when n is 1, 2, and 3, it would be 8, 16, and 24. And then, so I'm trying to get the numbers of the sequence 3, 11, 19. So to get from my 8n to what I'm trying to find out is added on to that sequence, it's being minus 5 each time. So I know that my sequence is 8n minus 5. Okay, so moving on. So question 4 says, work out the lowest common multiple of 20, 30, and 40. I do have a video on lowest common multiple, highest common factor, and prime numbers in the link above. So quickly, what I'm going to do is work out the prime numbers of 20. So 10, 5, 5, oh, wow. 10, 2, circle 2 because it's a prime number, and then 2 and 5, circle that. Then of 30, 3, 10, 10's a prime number, and then 2 and the 5. And then for 40, you can go 2, 20, and then 20 into the 10 and the 2, and then the 10 into the 2 and the 5. So normally with lowest common multiple to do with 2 numbers, I would draw a Venn diagram, but a 3-way Venn diagram can confuse people sometimes. So what we're going to do is we're going to look for the numbers that they share in common. So 20 has 2 2s, so they both have at least 1 2 each because we've got a 2 here. So I'm going to tick the 1, so 2, 2 and a 2. So I'm going to put that away, and then whatever I've ticked off, I'm going to cross that out because, again, that might complicate people. And then they all have a 5 in common. So now the 40 and the 20 also have an extra 2 in common, so like 1 here, 1 there. So I'm going to cross them 2 out and write that down. The 30 has a 3 on its ones. And then the 40 has an extra last 2. So then 2 times 5, again, you can put this all into your calculator, but I'm just going to work out quickly. So 2 times 5 is 10, times another 2, which is 20, times the 3, which is 60, times the 2, which is 120. Because remember, lowest common multiple, to work it out, it's all the numbers that they share in common, that would just be that one on its own. And then any ones that it has on its own, times that. So all of them times by each other. So the only one 120 is there. So now, just so we can clearly see the next question, it says the length of a table is 110 centimeters to the nearest centimeter. So it wants me to complete the error interval. So with error interval, if it's to the nearest centimeter, we will know 1 centimeter. So half of 1 centimeter is, so divided by 2 is 0.5 centimeters. So then now my error interval is going to be 110 plus 0.5 to give my highest value, which would be 110.5. And then the lower end of my error interval would be 110 minus 0.5, which would be 109.5. And if you would want to use your calculator to work that out, you can, because this is a calculator paper. So 109.5. Okay, so moving on to question 6. I'm going to zoom out so you can clearly see the question. So it says a music festival has taken place each year from 2011, and it says the table shows the number of people who attended each year. So it shows number of people attended between 2011 and 2018. So it now shows that the first 4 years have been plotted, and I'm guessing they're going to want us to complete it. But let's see what it says. Yeah, I thought as much. Part A says literally complete the table, so we will do that. So we zoom in to where the information is. Yeah, so literally this one, you're just plotting on. So they've done it up to 2014. So let's carry on to 2015. So 2015, they had 2,023 people. So again, that would be roughly, so each box, little box going up is like 100 extra people. So it'll definitely be less than that. Oh, wrong year. And then for 2016, it was 2,612. So 2,600 is above there, about there. And then 3,251. Again, this one, like, they just want to see if you're roughly in the right place, because obviously you're not going to get it on the nail, because of just how small the actual accuracy is. And then 2018 was 3,780. Yeah, about there. So I've plotted the points on, and then it says use the graph to estimate the number of people who attended the festival in 2019. So first of all, I'm going to connect my lines. Estimate the number of people that attended the festival in 2019. So, in order for us to estimate the number of people, what we will need to do is we're going to roughly continue on where we think the line would continue on to. So I'd say that's a good average, like a good approximation. So if that's 2019, then that would be our kind of mark for 2019, which is looking like an estimate of 4,350, since it's kind of between them. So that's what I'm going to go with my approximation. But to be fair, the mark scheme, so I'll put what range of values the mark scheme allowed. Mark scheme allowed any answer between, to get the full 2 marks for that question, the mark scheme wanted answers between, just got it, answers between both values 4,300 to 4,350, so I just got it for 2 marks. And then for 1 mark, they allowed it if 1 mark they allowed quite a lot. So 1 mark they allowed if you got 3,780 to 4,200. Even if you got an answer greater than 4,500, they allowed it as well. So I'll just put also greater than. So yeah, to be honest, I'm sure most of you would have at least gotten 1, but to get that 2, you would have had to be mad accurate. So, but I'm sure you will. I'm sure you will. All right. So question 7 says Mo says that K is a prime number. Oh, Mo says that k is a prime number for all integers of n from 1 to 9. So it says we want to show that Mo is wrong. Okay, so we've got n squared plus 9n plus 1, and he's saying it's a prime number for all integers of n from 1 to 9. Well, let's have a look. We know that our prime numbers between, well, for all integers between 1 and 9, let's have a look. Let's test with 1 first. So when n, I need to go back to black. When n is equal to 1, right, you're going to have 1 squared plus 9, because 9 times 1 plus 1. And so 1 squared is just 1, 1 plus 9 is 10, and then that's equal to 11. Okay, so for that point, it is a prime number because we know 11 is a prime number. And then if we have a look at when n is equal to 2 per se, so 2 squared plus 18 plus 2, so 2 squared is 4. Again, you could just put this all into your calculator. I'm just working out in my head. So 4 plus that is 24. And we know that 24 is not a prime number. And then I'm going to use another one just to see if my point is back. Pick another number between 1 and like 5. So 5 squared plus 45 plus 1. Oh, I just realized there. It would be plus the 1. So it would be 23. Okay, 23 is a prime number. So 25 plus 45 plus 1. That would give you an answer of 71. Oh, that's also a prime number as wrong. So we're meant to show that that Mo is wrong. All right, let's keep going. So let's say if n is equal to 7, so 7 squared plus 63 plus 1. So if you put that into your calculator, so 49 plus 63 plus 1, that is 113. Okay, so that's not worked as well because these are all prime numbers. Oh gosh, we're trying to show that he's wrong. So prime number, prime number, prime number. Okay, surely there will be 1, right? Okay, so let's say if n is equal to 6, then we would have 7, sorry, not 7, 6 squared plus 54 plus 1. So quickly inputting that into my calculator. So that's 36 plus 54 plus 1. Aha, we have 91. And 91 is not a prime number, lads, because 91 is divisible by 13. So 91 divided by 13 is 7. And so it's divisible by 13 and 7 because 91 divided by 7 would give you 13. So when n is 6, no is wrong. And I hope that makes sense. That one is literally trial and error one. With questions like this that you know is kind of like you have to literally test them all. Obviously, because it's a calculated paper, you'd be able to do this relatively quickly. But if this for you would take a long time, then I would come back to this towards the end. All right, so let's move on. Let's have a look at question 8. So it says Doug owes an amount of £600. He wants to pay this amount off in 5 months. He says each month I'll pay about 20% of the amount I still owe. So show working to check if his method is correct. Okay, so he wants to pay this off in 5 months. Let's see. Well, if let's say after month 1, he's going to be paying off 20% of 600. So you can just put into your calculator 600 times 0.2. So that would be £120. So then he would be left with 480. So then for month 2, he's going to be paying off 20% of 480. And that would leave you with an answer of 96. So then if you did 480, take away 96. 480, take away 96, you'd be left with 384, and then month 3. Again, a quicker way to just, I'm just showing you the long way if that's what you prefer, but a quick way of just figuring out what he'd be left with after paying off 20% is, rather than times them by 0.2 and taking it away from what you originally have, do the answer that you have times 0.8. That's also quicker. So then 384 times 0.8 would be 307.2, and then after month 4, 307.2 times 0.8 is 245.76, and then, oh, it's not looking promising that he's paid everything off, but let's have a look. So then the 245.76 times 0.8 is equal to 196.608, but in terms of money, we want it to 2 decimal places, so that's 196.61. So realistically, this man has been left with still close to £200 left to pay off. So his method is, he still has £196.61 left. Therefore, his method is incorrect. Okay, so let's have a look at question 9. So question 9 is going on about how a motor racing circuit consists of 2 parallel lines, each length of 0.75 kilometers, a semicircle of a diameter of 0.9 kilometers, 3 equal and smaller semicircles, and it says the length of the motor race must be greater than 305 kilometers. What is the lowest number of full laps needed at this circuit? So let's have a look. Okay, so in regards to this, so the first thing is that we need to work out what this part is, the length of that, and that's basically the circumference of a semicircle. So now we know the diameter would be 0.9. So we know for circumference it's pi times diameter. That's one of the ways of working it out. So it'll be 0.9 times pi, and then divide by 2, since we've only got half of it. So if you put that into your calculator, you should come up with an answer of about 1.4, so on. So then now, in order to work out these lengths as well, remember that these are 3 semicircles that are equal. So we're going to do the 0.9 divided by 3. So then each of those will be 0.3. So then to work out the circumference of at least one of them, of one of the mini semicircles, one of the semicircles, it'll be 0.3 pi divided by 2, and then that basically times by 3. So then that's essentially the same as doing the 0.9 pi divided by 2. You should end up coming up with the same answer as your total. So that would also give about 1.4 dot dot dot. And the reason why I'm saying that is because one of them would be about 0.47. So then times that by 3, and you should get in your calculator 1.4 dot dot dot, because you've got another one here and another one here. So yeah, moving on, we've got 2 of those 1.4s, so that'll be 2.8, so on. So then the last step is you need to add it to the 2 lengths here. So you've got 2 lots of 0.5, so 0.5 times 2 into your calculator is 1.5. So then add 1.5 onto there. That should give you a total of around 4.3. So then the last step is, it now says the length of the motor race must be greater than 305 kilometers, and it wants us to work out the lowest number of full laps needed to complete this circuit. So in order to work out the number of full laps, we need to do 305, which is the total length of the motor race, divided by what we have of the circuit so far, which is divided by 4.3, and so on. And if you put that into your calculator, you should come up with an answer of about 70.4. So 3 significant figures in terms of numbers of laps. But obviously you can't do 0.4 of a lap. So to fully complete it, since you want it to be greater than 305 kilometers to be completed, it would be 71 laps. And I hope that makes sense. Okay, so moving on to question 10, it says it wants us to solve this inequality equation of 8 is greater than 3 minus a half x. So let's have a look at this. So the first thing is that it's like solving inequalities confuses people sometimes because they see the signs and they think, oh, I don't know what to do. Solving inequalities is the same way as solving other equations. The only difference is that rather than having an equal sign, you have a less than or more than sign. So we're going to do the same method. So in order to do this, you want to make x the subject. So I'm going to take away 3 from both sides, which would be leave me with 5 is greater than minus a half x. And then I'm going to divide by minus a half x on both sides. And obviously you have a calculator to do this if you want. So then dividing by minus a half should give you an answer of minus. Okay, that should be minus 10. So let me change that. Minus 10. And then because it's now flipped, so here it was positives, right? And this was negatives. Because that's going to flip to minus 10 and then you'd be left with x. Because the positives and negatives change, the sign is going to change as well. So rather than it being greater than, it's going to be a less than sign. So now you could leave your answer like this, or another way of writing it is some people prefer to write the x first. But if you're going to swap the x with the minus 10, again, you're going to end up swapping the signs as well. So signs swap when the positive and negatives on the opposite sides change, or when you swap them around. So that would be to the minus 10. Okay, so moving on to question 11, it says using trigonometry, aka Circumference. So Circumference, first step is you want to label it. So adjacent, hypotenuse, opposite. We've got our adjacent and hypotenuse, so we're going to be using K, also known as cos. So it's cos x is equal to our A, which is 9 over 10. So then in order to work out the angle in SOHCAHTOA, remember you want to do inverse. So x will be equal to inverse cos, aka cos minus 1, which in your calculator press shift, then cos, and then put in the bracket 9 over 10, and then put that all in, and that should give you an answer of 25.8 degrees, or you can put 26, either way, mark scheme allowed it. Okay, so moving on to question 12, Lewis wants to draw a graph, a cubic graph, from values x from minus 2 to 2. So here is the graph that Lewis drew. So I have to make a criticism on it. Well, the criticism is not to say that his points are invalid, but anytime that you have a quadratic graph, a cubic graph, any type of indice graph, it shouldn't be straight lines that's looking higgy-haggy like this. The graph should be curved. So graph should be curved. So obviously I'm not expecting you to draw over it in the exam, but I'm just showing you what it should look like. So it should look like that, something like that. But notice how it's more curved. So sorry, Lewis, make it curved next time. Right, so question 13. Probability of a heads when a biased coin is thrown is 0.6, and it says the coin is thrown 500 times. I have to circle the expected number of tails. Well, if it says for a heads is 0.6, then for a tails, it's going to be 1 minus 0.6 because total probability adds up to 1. And on a coin, you can either get heads or tails. You can't really get anything else. So 1 minus 0.6 is 0.4. So if I put into my calculator 0.4 times 500, you would get an answer of 200. So that would be that. Then moving on to question 14, it says the mean mass of a squad of 19 hockey players is 82 kilograms. A player of a mass of 93 joins the squad. So work out the mean mass of the squad now. Well, I need to work out the total mass out of everyone. And to do that, I'm going to put into my calculator 82 times 19, which would give me 1,558. Now I need to add the extra weight of the squad member, which is 93. And so that would leave me with, in my calculator, 1,651. And now because I've added an extra player, I'm not going to have 19 squad members in total. I'm now going to have 20 squad members. So now to work out the mean mass, I need to do that, divide by 20, and that should leave you with 82.55. Or you can round that to three significant figures and 82.6. So either one of those, the mark scheme allowed is your final answer. Okay, so having a look at question 15, it says a company makes two types of lampshades using fabric on wireframes. So you've got lampshade A, which is fabric used to make the curved surface of the cylinder, and it says the cylinder has a radius of 8 centimeters and a height 22. Then you've got lampshade B, which, makes four triangular faces of a prism, and it says each triangular face has a base 15 centimeters and perpendicular height of 24, which is shown on the 2D surface here. So then going on down, it now gives us the cost of the fabric and it says other costs for A and B for each lampshade. So overall, it wants us to work out the ratio cost of lampshade A and cost of lampshade B. So in order to work this out, before we work out any cost, we need to first of all work out the areas of both lampshade A and lampshade B. So looking at lampshade A, it's just the fabric covering the curved surface. So it's not going to cover the flattened circle parts, just literally this curved part of its shape. So then how we need to do that now is we first of all need to work out the circumference. Oh, let me spell that correctly. Which is pi times diameter. We know the radius is 8, so the diameter would be 16 centimeters. Now for this, if we just have a look down for a second, it says that for the cost of the fabric, when we eventually work out the area, it wants it in square meter. So you have two options in terms of working this out. We can either work out the surface area of this cylinder in meters, so convert all the measurements in centimeters to meters, which would be 0.16 meters and then 0.22 meters. Then do your working out, or you can work it out in centimeters and divide it all by 100 squared. So either way is fine. I'm going to do it by converting everything to meters. So then that would be 0.16 times pi times 0.22, which would be 0.0352 pi if you put that into your calculator, and that should give you an answer of around 0.1105. Then, now that we've worked out the area of lampshade A, let's work out the area of lampshade B. So going on to lampshade B, it says the fabric is used to make the four triangular faces. So literally just the four triangles. We don't need to work out the area of the square. So they've got the triangular face here. So we know the area of a triangle is half base times height. So that'll be half times 15 times 24. But because there is four triangular faces, that would be multiplied by 4, which would be 720 if you put that into your calculator. But again, the same thing here, that is given in centimeters. So you can either do the 720 and then divide by 100 squared, or again, just convert everything to meters. And I'm just showing you both ways. So just so you know that there are usually more than one way to work out things. So that'll be half times 0.15 times 0.24. And then all multiplied by 4. And then your calculator that should leave you with 0.072 meters squared. Okay, so now we've got the area of lampshade A, we've got the area of lampshade B. Just going to make note of their areas here. So that was 0.105, and then B was 0.072 meters per second. Okay, so now let's zoom in so you can just have a clear perspective of what's going on. The next thing is now we need to work out the costs with the fabric. So if we look at which lampshade A, right, the cost is going to be the area times 400, since it's 400 per square meter. And that would give you an answer of 44.24 roughly. And then in terms of B, that would be 0.072 times 400. And that would leave you with about £28.80. Okay, so now that we've worked out that, there's other costs for A and other costs for B. So we need to add the other costs per lampshade on. So because it's only the ratio of one lampshade, we're just going to add one lot of the £3.50 and then add one lot of the £7.50. So let's look at A. Put those numbers into your calculator. You should come up with 47.74. So £47.74. And then for B, you would end up with 30, or 35, sorry, £36 and 30 pence. So now, because we need to leave them as a ratio, so make this straight. So 47.74 to 36.30. So now, as a ratio, one of them would be equal to 1. So we can just divide by 36.30, as that's the smallest number. And if you put 47.74 divided by 36.30 into your calculator, you should get an answer roughly of 1 point. So let me do it now quickly. 47.74 divided by 36.30, you'd get an answer of roughly 1.315, so on, so on, so on. So in regards to the mark scheme, they allowed with 1.15, so on, so on. But in the NETA version, you could have round that up to 1.32, and they allow that to do. They allow that as well. And then obviously 36.3 divided by itself would be 1. So this would be this as a ratio. Okay. So obviously, again, just to reiterate, we left it in this format because that's the format they wanted it in. So having a look at question 16, it says, in a running club, there are 50 females and 80 males, and it says that if a female is chosen at random, the probability that she has blue eyes is 0.38, and if a male is chosen at random, the probability that he has blue eyes is 0.6. It says one person is chosen at random. Show that the probability that the person has blue eyes is more than 0.5. Well, having a look at this, we know that there are 50 females, and the probability of a female having blue eyes is 0.38. So if we did the number of females, which is 50, times the probability of blue eyes, 0.38, onto your calculator, you would get 19. And then same for the males. So for the males, there was 80 males. The probability is 0.6. Multiply them together, you would get 48. So we know that those that have blue eyes out of male and female, out of their total of 130, because if you add them together, so now add together the 19 and 48 into your calculator, you get 67. So that means out of 130 males and females, 67 of them have blue eyes. So we're trying to show that the probability that the person has blue eyes is more than 0.5. So in your calculator, you need to put in that 67 divided by 130, and so that should give you an answer of divided by 130, 0.515, so on, so on. So this value of 0.515 is more than 0.5. Therefore, the probability that the person has blue eyes is more than 0.5. Okay. Right, so moving on to question 17, it says W is equal to 3 over 5 root x. So it wants us to circle the expression of W squared. So therefore, W squared would be equal to all of that part squared. Okay, so when it comes to squaring fractions, square the numerator and then square the denominator. So 3 squared would be 9, and then 5 root x squared. So 5 squared is 25, and if you square a root x, so that's basically a third root x, you would get just x, so that would be 25x. So 9 over 25x would be the answer. So it would be this one. It wouldn't be this one because root x squared does not give you x squared. If it was x squared, that would give you x squared. Okay. So that's that one. And then on to question 18. So it says, here is some information about ages of people in a concert. Just zooming out so you can see everything. So it's given us this table and it basically wants us to draw a histogram. So in regards to drawing a histogram, the first thing is that we need to work out the frequency density of each of these class intervals. So I'm going to add an extra column for frequency density. And frequency density is frequency divided by class width, aka the difference in each class width. So the first one would be 8 divided by 5 into your calculator, which would be 1.6. Next one would be 24 divided by 10, because that's the difference between 25 and 15, which would be 2.4. 30 divided by the difference between 40 and 25, which is 15, which is 2. And then the last one, 39 divided by the difference between 70 and 40, which is 30, which in your calculator would be 1.3. So now we've worked out all the frequency densities, we need to draw our bars. So histograms are a type of bar chart when the bars are all touching each other. So the first one would be the first class width. So that's from 10 to 15. And then its frequency density, aka the height of the bar, is 1.6. So I'm going to draw a line of where 1.6 would be, which would be there. Then I'm going to draw down. That's the first one. Then the next one is 15 to 25, so 25 is there. But it goes up to 2.4. So that's about there. Obviously, use a ruler for these. It's just because I'm doing it on a virtual board. So then 25 to 40, the height would be up to 2. And then the next one, 40 to 70, the height's up to 1.3. Okay, so that's actually the histogram. And then moving on to question 19. So it says the length of a roll of ribbon is 30 meters, correct to the nearest half meter, and a piece of length 5.8 meters, correct to the nearest 10 centimeters, is cut from the roll. It wants us to work out the maximum possible length of the ribbon left on the roll. Well, let's break this down. First off, in terms of the length of the ribbon, it's correct to 30 meters for every half to the nearest half meter, aka 0.5 meters. So in regards to that, we need to work out the maximum length of the roll in general and the minimum. So maximum, minimum. So the maximum would be, so it would be 0.5 divided by 2, because remember, it's whatever it's corrected to, half that. So that'll be 0.25. Add that on to 30. So 30 plus 0.25 is 30.25. Then from the lower end, you take away 0.25 from 30, which would be 29.75. And then it says a piece of length of 5.8 meters correct to 10 centimeters is cut off. So 10 centimeters in meters is 0.1 meters. Divide that by 2, that would be 0.05. So that highest value would be 5.8 plus 0.05, which would be 5.85. And then the lower end would be the 5.8, take away 0.05, which would be 5.95. So we're working out the maximum possible length of the ribbon left on the roll. So in order for us to have a maximum length left on the roll, we want to use the biggest possible length, take away the smallest possible length. Because if we take away from the biggest possible length, then it's not the maximum possible value left. Oh, I just realized I wrote 5.75. Yeah. So we're going to do 30.25, take away 5.75 into your calculator. That will give you an answer of 24.5. So just remember that it's very important to read what the question wants from you. Okay, so moving on. So on to question 20. It says curve P has equation y is equal to 2 bracket x minus 1 squared minus 5, and it says curve Q is a reflection in the y-axis of P. So it says work out the equation of curve Q, and it wants us to give it in a quadratic formula format of ax squared plus bx plus c. So let's dissect this question very easily. So with curve P, this is written in complete in the square format, as we can see. So what we need to do is, because curve Q now is a reflection in the y-axis of curve P. So roughly draw a sketch, because it's always nice to visualize things. So let's say if this is P, then if Q is reflected in the y-axis, then it would be like this. So this is like our equivalent of the Q. So notice how with Q it's come up with more negative values of x. So then we're going to substitute x for minus x. So then that will be y is equal to 2 bracket minus x minus 1 squared minus 5. So now we have this, we're going to expand. So that'll be 2, so minus x minus 1 minus x minus 1. So let's expand first. So minus x times minus x is x squared, minus 1 times minus x is plus x, minus 1 times minus x again is plus x, and then minus 1 times minus 1 is positive 1. Then we're going to simplify what's inside our brackets. That will be x squared plus 2x plus 1 minus 5. Then we're going to expand the bracket, so that will be 2x squared plus 4x plus 2. Take away the 5. So 2 minus 5 would be minus 3. So, and if you have a positive and negative next to each other, it becomes negative. So now we've got this, and that would literally be our answer, because that's the format that it wants us to leave it in. So the key thing to remember is, if you're reflecting in the x-axis, remember your x-axis is basically equivalent to is here. And so if you reflect in your x-axis, what would initially be positive as an x would become negative as an x, and vice versa. So just remember that. Okay, having a look at question 21. Priya and Joe travel the same 16.8 kilometers route. So Priya starts at 9 a.m. and walks at a constant speed of 6 kilometers per hour, whereas Joe starts at 9:30 and runs at a constant speed. Joe overtakes Priya at 10:20 a.m. So we need to figure out what time would Joe finish the race. So what we can figure out is, if we know that they both travel in 16.8 kilometers, we can work out when, since Joe overtakes Priya at 10:20 in the morning, we can work out the distance that Priya has traveled from 9 a.m. up to 10:20. And because at that point he overtakes her, he would have traveled the same distance. Then by knowing his distance at 10:20 a.m., we would therefore know his speed. And by knowing his speed, we can work out what time he finishes. So let's work it out bit by bit. So for Priya, from 9 a.m. to 10:20 a.m., her time is 1 hour 20 minutes, right? So in terms of working out her distance, so I'm going to draw the triangle for it. Speed equals distance divided by time. So distance for Priya is going to be equal to speed, which is 6 kilometers per hour, times the time. So the time would be, if we convert this as a decimal, it would be 1 hour. So it will be 1.33. But obviously it's 33 recurring. So what I would do is put into your calculator it as a fraction per se over maybe 60. So that would be 80 over 60, because 1 hour 20 minutes is the same as saying 80 minutes. So 80 over 60. That's the same thing. So now that we've got this, so it will be just writing it neater. So 6 times 80 over 60. So then if you were to put that into your calculator, you would get an answer of, so 480 over 60. Oh, that would convert to make 8. So we know that Priya has travelled 8 kilometres by 10:20 in the morning, which means Joe has also travelled 8 kilometres by 8 a.m. So to work out his speed, we're going to do this distance, which we worked out as 8 kilometers, divided by the time. So because Joe started at 9:30, and when he overtakes Priya is 10:20, he's only just traveled for 50 minutes. So as a fraction, that would be 50 over 60, because it's 60 minutes in an hour. That's why we did over 60 here as well. So then 8 divided by 50 over 60. So remember, if you ever divide by a fraction, you can flip it and then ends up multiplying. So 8 times that. So then if we were to work that out into our calculators, that would leave us with an answer of 480 divided by 50, 9.6. So then now that we know that Joe's speed is 9.6 kilometers per hour, we can now work out the time that he finishes the race. So in order to work out his time that he finishes the race, we need to do the total distance, which is 16.8, using our triangle of our formula here. So time is distance divided by speed. So that'll be 16.8 divided by 9.6. And if you put that into your calculator, you should come out with an answer of 1.75. Obviously, you can't leave it as 1.75 of an hour, because that's just telling you that it's going to take him 1.75 hours to finish it. But if we convert 1.75 into minutes, that's the same as saying 1 hour and then 0.75 times 60 in your calculator, if you don't know how to work out, would be 45 minutes. So then that would be 1 hour 45 minutes. Joe started at 9:30, so then 9:30 plus an extra hour would get us to 10:30, plus the 45 minutes would leave you at 11:15 a.m. So we know that Joe is going to finish the race at 11:15 a.m. Okay, so going on to question 22, here it's an approximation question where it wants us to work out the values x2 and x3. So we know what x1 is, so x2 is going to be so remember, if it's n plus 1 here, then when we're working out x2, we're going to be doing what x1 is, cubed, minus 2 over 10. x1 we've been told is minus 1, so that'll be minus 1 cubed, minus 2 over 10. You can just shove that all into your calculator, since this is a calculator paper, and that should leave you with an answer of, say, minus 1, minus 2, minus 3, minus 0.5. And then x3 would be, rather than now x1 cubed, it will be x2 cubed. And so that would be minus 0.3 cubed minus 2 over 10. Put that into your calculator, and that should leave you with minus 0.2027. So minus 0.3 minus 0.2027. Okay, fab. Then part B then says work out the solution to 5 decimal places. So remember, approximations is just when you're getting closer and closer to the exact value of x. So in terms of working it out here, what we can do is we're going to do it again, another approximation, because it wants the solution to 5 decimal places. So this time we're going to work out what x to the 4 is. So then x to the 4 would be minus 0.2027 cubed minus 2 over 10. And by putting that into our calculators, that should leave us with an answer of minus 0.2081. And when we have a look at this is to 5 decimal places, which is what they want. So in scenarios like this where it wants it to a certain number of decimal places, just approximate it again. So now having a look at question 23, it says a diagram shows a side view of a step ladder with a horizontal strut of length 48 centimeters. The strut is 1/3 of the way up the ladder. Then it now says the symmetrical cross-section of the ladder shows two similar triangles. So we're trying to work out the vertical height of the ladder. So this is all to do with similar shapes, and a bit of Pythagoras, which I do. I will put those two videos in the link in the description box down below if you want to revise those. So I'm going to split it out because sometimes people find it easier of answering this to split it out. So with the smaller triangle, I'm going to put that, and then the bigger triangle, we know that that was 141, and so we don't know any other part of this information. And then that is going to be our height. So the first thing that we can do is we can work out the base, because it says that the strut is 1/3 up the ladder, which tells us that this 1/3 up the ladder. Okay, so that tells us that this height here, so this part is 1/3, so that would be 2/3. Right? So if we look at the height, so 2/3 of the height is in the smaller triangle, and we've got h in the other triangle. So to work out the scale factor, we know that the height in the smaller triangle in terms of a ratio is 2/3 of the height to the height. So then cancel out the h's, that's 2/3 to 1. So then to work out the scale factor, you want to do the bigger value divided by the smaller one. So the second length over the smaller length, the first length, aka the smaller length. So that would be 1 divided by 2/3, divided by a fraction, you flip it and it ends up multiplying. So 1 times 3/2. So it will be 3/2. So now in order to work out this bigger length, to go from the smaller length to the bigger length, we would need to times by 3/2, because you want to go from smaller to bigger. So you want to multiply that, and the other way around, you would divide by 3/2. So we're going to do 48 times by 3/2. So if you put that into your calculator, you should come out of an answer of 72. So now we know that bottom part is 72 centimeters. Okay, so now that we know that, that's going to help a lot in terms of our Pythagoras. So having a look at this big triangle again, I'm going to split the big triangle into two right angles. So then I know that that's 141. If I know the whole base is 72, then 72 divided by 2 is 36, right? So that's going to be 36. So then to work out the height, which is what we want to work out, we are going to use Pythagoras. So our a squared plus b squared equals c squared. So I'm going to call this c, a or b. Remember, a or b, it doesn't matter where they are. So then to work out, it will be 36 squared plus b squared is equal to 141 squared. B squared is therefore 141 squared minus 36 squared, and then b would be the square root of all of that. And if we put this into our calculators to work out an answer, you should get an answer of 136.2 something something something, or something along those lines. They allowed anything between 136.2 or 136.4, or they even just allowed it if you rounded it to 136. So that's what I'm going to do. Okay, and then looking at question 24, it's given me the volume of a sphere equation, and it's given me the volume of a cone. And it's basically saying that this sphere has a radius of 2x. So I'm just drawing 2x. Excuse a really bad drawing. And then it says the cone has a radius of 3x, as a center, 3x, and a perpendicular height of h. And it says that the sphere and the cone have the same volume. It wants us to work out a ratio of the radius of the cone to the perpendicular height of the cone. So if we know that the sphere and the cone have the same volume, we can work out the volume of the sphere, because we know that the volume of the sphere equation is 4 over 3 times pi times r cubed. So we know what the r is, it's 2x, so it will be 4 over 3 times pi times 2x cubed, which would be 4 over 3 pi times 8x cubed. Then we can do the 8 times 4 over 3. So that would be 32 over 3 pi x cubed. So now to work out the perpendicular height, that's basically the volume of the sphere, right? And because that's equal to the volume of the cone, so that's going to be equal to a third pi r squared h. So then having a look up. So now we want to work out what is going on. So we can cancel out the pi's. And then also we've got 32 over 3 on one side, and then we've got a third on the other. So the thirds can cancel out, leaving us with 32x cubed, and then 1 would just be 1. So anything times 1 in itself. So essentially that can go. So then now we've got that. Then we know that the radius of the cone is 3x. So I'm going to substitute that for 3x. So it will be 3x squared. And we know 3x squared would be 9x squared. So now we've got this. So what we can do is we can divide both sides by x squared. And that would leave us with 32x is equal to 9h. So now to work out what h is, it would be 32 over 9x is our h, because what I just literally did was divide 9 on both sides. So now I know what my h is. It wants me to write in a ratio against the radius of the cone. So the radius of cone is 3x. The perpendicular height, which is 32 over 9x. So then we could simplify this essentially by dividing both sides by 3. Sorry, by multiplying both sides by 9. And by doing that, you've removed the fraction. So then that would be 27x to 32x. And then the last bit is you've got nice whole numbers, no more fractions. So then the final step really is to get rid of your x's, because they both have x on both sides. And that would leave you with a ratio of 27 to 32. Okay, moving on to question 25. You've got a quadrilateral ABCD, and it says the quadrilateral is reflected in the line x is equal to 4. So it's saying which vertices are invariant. So let's break down what invariant means. So think of the word vary, right? The English word vary. Just mixing a bit of maths with English, why not? Vary means something's to change. Like, it varies, it changes. So if something's invariant, whenever you've got in front of a word, it's like different, indifferent. It's like the opposite. So it's something that's not going to change. So it's basically the 2 points that are not going to change. So we need to draw our line x is equal to 4. Which would be a straight line here. So if we were to reflect it in that line, the only 2 points that are not going to change is our B and our C. Our A and D has changed, so it's those two. And then going on to question 26, it's given us an equation, and it's basically asking us to work out the inverse of the functions, all to do with functions. So the method I like to use when working out inverse functions, so I like to replace in the f of x with y, because y is basically the same as f of x, if you haven't noticed. Then with working out inverse functions, we're basically going to swap all the x's with the y's. So it's going to change into this. So now that we have this, we need to now rearrange this to make it y is equal to. And that's the same as working out the inverse, aka f minus 1 x. So let's do that. So first things first, we're going to multiply both sides by y minus 4. And that's going to be like this, 2y plus 3. So expand the brackets, that will be xy minus 4x is equal to 2y plus 3. Collect the y's to one side, collect everything else to the other. So then that will be xy minus 2y is equal to 4x plus 3. Now factorize and then divide both sides by x minus 2. X minus 2. So we can happily say that f of x, or f minus 1, x, is equal to 4x plus 3 over x minus 2. And on to question 27. So question 27 says that the line y equals 3x plus p and the circle equation x squared plus y squared equals 53 intersect point A and B. So it wants us to show that the x coordinates of both points A and B satisfy this equation. So if you've got two equations, right? So two equations and they intersect at the same point, and that basically means that points A and B, they've got the same x and y values. So if they've got the same x and y values at those points, we're basically going to make them equal to each other. Or in this case, because you've got a circle equation, we're therefore going to substitute the equation of this line into for y in the circle equation, since y is equal to that. So that would be x squared plus 3x plus p squared is equal to 53. We're going to expand this bracket. So that will be 9x squared plus 3xp plus 3xp. Because remember, if you've got a bracket squared, just to show people what I did, it's basically like the same as having the two brackets next to each other. And then it's like quadratic expansion. Yeah, the 9x squared, 3xp, and then 3xp again, and then now p squared. So then now simplify. So you've got 3xp plus 3xp. So that's going to be 9x squared plus 6xp plus p squared equals 53. And then bring down the x squared from before. So then plus the x squared. Now add the two x squareds together. That's going to give you 10x squared. And we're getting closer to what we want because our answer seems to have a 10x squared involved. So we've got the 10x squared, we've got the 6p. Oh, we've got the p squared as well. The only difference is that they've got minus 53 and we don't. So we're literally just going to take away 53 from both sides. That's going to help make it equal to 0. And that's going to leave us with the answer that they want. And that's that. Okay, so on to part B. It says write down the coordinates of A. No, it says the coordinates of A are 2, 7. So it wants us to write down the coordinates of B. So let's have a look. So it wants us to write down the coordinates of B. So what we can do is we can substitute the coordinates of A, which were, if I scroll down again, 2, 7. I'm just going to rewrite it here so I don't forget. So A is equal to 2, 7. We can substitute the coordinates of A into this equation to work out what P is. So I'm just keeping on this page, even though the question's on the other page, but just so you can see the equations and things like that, and it saves me from rewriting the whole thing. So coordinates of A were 2, 7, right? So we're going to substitute that. So that'll be 7 is equal to 3 times x, so 3 times 2, which is 6, plus P. So then P would be 1. So now we know P is 1. We're going to substitute P as 1 into that. So that would be 10x squared plus anything times 1 is itself. So that's just going to be 6x. And then 1 squared is 1. So minus the 53 is equal to 0. Then 1 minus 53 would give us minus 52. Okay, so now we've got a quadratic equation, and then we can actually divide everything by 2 because they're all divisible by 2, which would leave us with 5x squared plus 3x minus 26 is equal to 0. So we need to factorize, right? So I'm going to factorize this. So it's going to be a double bracket factorizing. So one of the brackets is definitely going to have 5x, the other one's going to have x. So now we need to think of different ways of multiplying to make 26 and that leave a difference of 3 when one of them is multiplied by 5. So you've got 13 times 2, 26 times 1. Not really much options, which is great. So if we were to times 2 by 5, that would give us 10. And the difference between 13 and 10 is 3. So it's a good thing that worked first time. So then that means that the 2 would go in this bracket because that's going to be times by 5. And then the 13 would go in the other bracket. But one has to be negative and one has to be positive and it has to leave a positive 3x. So the best way is if you have plus the 13, because that would make positive 13x, and then take away 10x. That would leave you with 3x. So now we've got our factorized brackets, we can work out the two values of x. So just to reiterate, right, and rewrite it down, our a coordinate was 2, 7, and we know one of the solutions is when x is equal to 2. So the other solution is when x is equal to minus 13 over 5. So that's going to be our x value for B. Is it making sense? So I'm just going to rewrite that here. So B, first of all, the x value is going to be minus 13 over 5, but we don't know what y is, so we can work that out. So to work out what y is, we're going to use the equation of the line y equals 3x plus p. So I'm going to rewrite it down here so I don't have to keep scrolling up and down. So y equals 3x plus p. Okay, so we're going to substitute our value of x. So then that's going to be y is equal to 3 times minus 13 over 5 plus p. So then that's going to be minus 39 over 5 plus p. We know p is 1 because we worked out what p is before. So if you put into your calculator minus 39 over 5 plus 1. So I'm going to work out manually. So that's the same as adding 5 over 5. So then that would be minus 34 over 5. So then if I put into my calculator 34 divided by 5, that would leave me with minus 6.8. So then my final answer for my coordinates for B is the x value is minus 13 over 5, or you can actually just put that as a decimal. Yeah, so you could literally either leave your answer as this, so leave them both as fractions, or, I'm just going to put the or, minus 13 over 5, you put that into your calculator, would give you 2.6, or negative 2.6, so you could put it as negative 2.6 minus 6.8. Either way is acceptable. Okay, so moving on to question 28, last question of the day and of this series. Okay, so it says here is a sketch of quadratic curve, and it says the turning point is 3 minus 2. So it says circle the correct statement about the gradient of the curve for x is less than 3. So first things first, we know what the turning point is. So when x is less than 3, this would be the gradient. So when x is less than 3. So what can we say about that gradient? Well, the slope is going down, isn't it? So if you have a slope that's going down, that means it's a negative gradient. That's literally it. And well done for getting to the end of this paper. I hope this was useful, guys. Please comment down below anything you would like. And thanks for watching.